Hello chemistry students, and welcome to your brief tutorial on the law of conservation of mass. Now, as you may remember from class, the law of conservation of mass states that in a chemical reaction, mass is neither created nor destroyed. So what that meant for us was that the mass of our reactants, or what we started with in the beginning of the chemical reaction, will equal the mass of our products, or what we end with. So let's look at two examples together. Number one, hydrogen and oxygen react chemically to form water. How much water would form if 4.8 grams of hydrogen reacted with 38.4 grams of oxygen? So our reactants in this problem are hydrogen and oxygen, and they react chemically to form our product, which is water. So I was given the mass of hydrogen and oxygen, so our reactants. So I started with 4.8 grams of hydrogen plus 38.4 grams of oxygen. Now, according to the law of conservation of mass, this will equal my mass of water. So when I plug that into my calculator, 4.8 plus 38.4 grams, I have that my mass of water, my product, is 43.2 grams. Simple enough. Alright, let's move on to our second example. When ammonium nitrate, or NH4NO3, don't worry, we'll learn how to name them later. So when ammonium nitrate explodes, the products are nitrogen, oxygen, and water. When 40 grams of ammonium nitrate explode, 14 grams of nitrogen and 8 grams of oxygen form. So how many grams of water form? Where our reactant in this problem was ammonium nitrate, and our products were nitrogen, oxygen, and water. So we started with 40 grams of our ammonium nitrate, and we know that because of the law of conservation of mass, it'll be equal to the mass of our products. And we had 14 grams of nitrogen and 8 grams of oxygen, and we were asked, well, how many grams of water do we have then? So I'm going to simplify this a little for us. So 40 grams, 14 plus 18 gives me 22 grams, plus the mass of my water I don't know yet, but I have a plan to get there. So when I solve this by solving for my variable, my x, I get that x, or the mass of my water, as 18 grams of H2O. Now, for help with taking this algebraic equation and manipulating it to solve for your variable, go onto Canvas and look for a link in our reference page. Thank you all for stopping by. If you have any questions, let me know in class. But I suggest go back and look at the starters and finishers and the problems in your practice packet. Bye!